Okay, friends, again, this is lesson 22, page 483. Let's talk about this whole idea of equivalent fractions a little bit more. Let's take a look at number 1, where my purple pen is pointing, and it says, the two circles here and two number lines shown are the same size. I think we can agree. These circles are the same size. These number lines, same size. It's asking us a couple of questions about these. Let's talk about that. Under 1A, it says to shade 1/2 of the first circle and 2/4 of the second circle. Well, before we do that, we need to take a closer look at the circles. So you can see, and we're going to talk about this maybe being pizza, right? We're going to talk about that being pizza. Let's say you order a pizza. You can see there are different ways to cut it. This pizza was just cut in half. This pizza was cut into fourths. But the pizza, it's the same size. The exact same size, just fractioned differently. So it's asking us to shade 1/2 of the first circle. All right, so 1/2 of the first circle. So let's do that together. There we go. 1/2 of the first circle. So I've done that. I can check that off. Helps my brain. I know I've done it. Multiple step problems require some organization, yes? All right. And then it's saying to circle 2/4 of the second circle. All right, so here's a 4th, and here's a 4th. 2/4. Awesome. All right. And so let's take a look at B. It says to label 1/2 on the top number line. Okay, label 1/2 on the top number line. So here's 1/2. Awesome. Did that. There's the check mark. Yay. And 2/4 on the bottom number line. Okay. There's 2/4. How do I know that? Because this number line is fractioned into 4 pieces. Here's a piece, and here's a piece, and here's a piece, and here's a piece. And I need to label 2/4. So here's 1/4 and here's 2/4. Awesome. There we go. All done. C is asking us, what can you say about the fractions 1/2 and 2/4? Let's take a closer look first at our pizzas that we just shaded. You can see here's 1/2, and you can see here's a 4th and here's a 4th. And you can very clearly see that the amount that we shaded is the same. It's the same. What this model is showing us is that 1/2 equals 2/4. Let's take a look at the number lines. Here's 1/2. Here's 2/4. They are the same point on the number line. So what can we say about these fractions? What we can say is this: they name the same part of the whole. And if we were to say it just in numbers, we would say 1/2 equals 2 fourths. 1/2 equals 2 fourths. Again, the same part of the whole is shaded. We could have split this into 8ths. We could have split this into 12ths. But if we shade the same part of the whole, those fractions are equivalent or equal. Now, friends, are we ready to have our minds blown? Minds blown. I am going to show you a quick strategy so that you can double check your own work. My students know I am all about that. You being able to check your own work. We talked a lot about inverse operations, for example, right? And how multiplication and division can check each other, how addition and subtraction can check each other. I'm going to show you a really quick way for you to see that you have, in fact, equivalent fractions. Does it take a little multiplication? It sure does, because this is what you do. In order for you to check your own work and confirm you have equivalent fractions, you're going to do what we call butterfly multiplication. What is it? I'm going to show you. You're going to take this numerator and this denominator and multiply it. You're going to take this numerator and this denominator and multiply it. So we have 1 times 4 equals 4. We have 2 times 2 equals 4. Products are the same. Do you have equivalent fractions? Yes, you do. Again, friends, butterfly multiplication. This is how you double check your work. If you are doing butterfly multiplication and your products are not identical, you do not have equivalent fractions. You need to do it again. All right. We're going to keep on going and talk a little bit more. Now, friends, on number 2, we need to be careful here. Here we go. It says different fractions that name the same amount of the whole are, again, equivalent. Different fractions that name the same amount of the whole are equivalent fractions. So here it's asking us to circle the pair of models. Circle the pair of models. So here's a pair, here's a pair, here's a pair that show 1/2 and 2/4 are equivalent. In order for us to do that, you need to remember what we're looking for in regards to how the models need to be the same size, first of all. That's a big one. All right, so we can see, first of all, it says to circle the models that show that 1/2 and 2/4 are equivalent. Let's take a look at this first pair. We can clearly see that they're 2 completely different shapes. They're completely different. So these are not showing equivalent fractions. These are completely different. So we're not going to look at that. That's not even an option. Let's take a look at this second pair here. Again, these pairs, they're not the same size, friends. They're not the same size. We cannot consider equivalent fractions for models that aren't the same size. So no, we're not looking at that either. Let's take a look at this third pair. These are the same size. Oh, great. This does, in fact, show equivalent fractions. Why? Because the exact same part of the whole you can see is shaded. The same part of the whole is shaded. That's how you know. All right, it's asking, how did you know which pair of models to circle in part A? How did you know? You know because the holes are the same size. The holes are the same size in the pair I circled. That's how you know. The holes are the same size in the pair I circled. All right, friends, let us move on to page 484. To page 484, looks like this. Now, up at the top on question 3, it says, once you make sure the holes are the same size, look at the size of the parts in each hole to name equivalent fractions. I'm going to read that again. Once you make sure the holes are the same size, that the holes are the same size, look at the size of the parts in each hole to name equivalent fractions. Let's take a closer look. Number A says to label each part of the models at the right with the unit fraction it represents. So again, friends, how do we write a unit fraction? Well, we need to know how many parts are in the whole. So when I take a look at this first one, I can see, again, I like drawing my fraction bars here. My denominator, or the number of parts in the whole, I can clearly see is going to be 2, because this whole is cut in half. So, okay. 1/2 and 1/2, awesome. I'm going to take a look at this second whole, and the first question I'm going to ask myself, how many parts are in this whole? 4. So my denominator is going to be 4. And of course, we're labeling unit fractions. And then I'm going to take a look at this next whole, and I'm going to say, how many parts are in this whole? And I'm going to say, 1, 2, 3, 4, 5, 6. That's my denominator, 6. Awesome. They're asking for unit fractions, so great. And then I need to ask myself on this whole, how many parts are in this whole? 1, 2, 3, 4, 5, 6, 7, 8. Great. That is my denominator. And of course, again, unit fractions. Awesome. I've labeled the model. Now, friends, I ask you, look familiar? Look familiar? Yeah. All right, now that we have our labels done, it's going to ask us some questions. So, question A says, to label each part of the models at the right with the unit fraction it represents. B says, shade the top model to show 1/2. Okay, so I'm going to use my pencil, I think, and just kind of lightly shade over my writing. There we go. Great. How many parts did I shade? 1. Shade the second model to show a fraction equivalent to 1/2. Second model, equivalent. Okay. Equivalent, so it's got to be this size. It's got to be this size. Okay. And I'll do one and nope, not quite there. Gotta do another one. There it is. And there you go. How many parts did I shade? I shaded 1, 2. Excellent. Number D is saying shade the third model to show a fraction equivalent to 1/2. How many parts did I shade? It has to be this size, right here, this size. I'm going to shade 1. Nope, not even close. I'm going to shade 2. Nope. I'm going to shade 3. Oh, there it is. That is equivalent. Perfect. How many parts did I shade? 1, 2, 3. Awesome. Shade the last model to show a fraction equivalent to 1/2. Here we go again. All right, I need to get this size right here. So there we go. Not close. Nope, not close. Nope. Oh, there it is. That's the same, equivalent to 1/2. How many parts did I shade? 4. Awesome. Anyone see a trend here? 1 part, there's 2 parts, there's 3 parts, there's 4 parts. It says to complete the equation using the models. So we can say that 1/2 also equals how many fourths? 2 fourths. How many 6? 3/6. How many 8s? 4/8. All the same, my friends. 1/2, 2 fourths, 3/6, and 4/8 are all the same. Why? Because the same part of the whole is shaded. It might be fractioned differently, but the same part of the whole is shaded. That is how we know that they're equivalent. Okay? How are we doing so far? How are we doing so far? All right. Let me show you a different, is anyone still having some issues with this? Having some confusion with this? A little bit? All right, let me show you this in a different way. I'm going to show you this in a different way, friends. All right. How many of you like chocolate? How many of you like chocolate? Let's take a look at some fractions. Let's take a look, friends. Here we go. Here we go. All right. Let's take a look. Here's a chocolate bar. This is a chocolate bar, friends. And you can see my chocolate bar. You can see that it's fractioned, right? It's got 12 pieces, 12 little squares, right? Now you can see that with my chocolate bar, I can fraction this in many, many different ways. I can say, for example, that I'm going to eat 1/2 of my chocolate bar, right? But I could also say, for example, I'm going to eat 6/12 of the squares. 6/12. Why? Because there are 6 pieces in this half of the chocolate bar. Same amount, friends. It's the exact same amount. I'm just fractioning it differently. I could break it in half, or I could say 6/12 and break it up into 6 different pieces. Maybe I'm hungry and I want to eat half of it. Or maybe I have 5 other friends over and they each want a tiny little piece, right? So let's say I only want to work with half of the chocolate bar. So if I break it all up, the big idea behind this, friends, is that it doesn't matter how that bar is broken up. I am still only working with 1/2 of it. Maybe I'm calling this a piece and this a piece, right? Maybe now I only have 1, 2, 3, 4 pieces. And I want to eat 2/4 of it. Maybe I'm breaking it up into 12. And maybe I'm eating 6/12 of it. Maybe I just snap it in half and I'm eating 1/2 of it. The bigger idea, friends, again, is that there are many different ways to name the same part of a whole. All right? Friends, we're going to come together for just a moment so I can take some questions before we start breaking out. All right?